Hello, everyone. My name is Daniel McClelland. I'm from TradeMe. Hopefully you're all here and able to hear me okay. Today's talk is called Making Your Espresso Sweeter. Apologies for anyone who is expecting a talk about how to make coffee. Unfortunately, this is not the talk for you, though some of you waking up very early in the morning or from Berlin may need some right now. This is going to be a talk about UI automation. Confronting the elephant in the room, UI tests are famously slow, easy to break, and hard to maintain. And I'm here to tell you that you don't need to worry. There are better ways to dealing with some of these things, and you can make your UI tests better. So we'll start with JUnit-based test class, and we're going to have a look at just how you would normally create an Espresso test. Some of you might not have ever done that before. So if you were to just follow the documentation online, then you would basically create a class that basically looks like this. It would kick off an activity in your app as a rule for how you begin your test, and your test would be defined with an @test notation up there. And if you were to crib from the Espresso-based documentation online, then you would have a bunch of ways of looking for identifiers and actions, and you would repeat that a lot throughout your test. And then you would find that you have a bunch of red squiggly lines essentially in your IDE, and you might wonder to yourself how you deal with that. And the answer, if you're very new to a lot of this stuff, is to just click import and make the red squiggly lines go away. So you get 10 lines of import statements there, and in your test itself that makes the red squiggly lines go away, so you feel happy. And then you start to wonder to yourself, what exactly have I just written? And so it's a little hard to read. It may be easier to just watch. So we'll kick off our test, which launches that activity. You click a couple of navigation prompts along the way to get to our login screen. And this test is a very brief test. It doesn't have any assertions in it. Those are a much longer topic to deal with than our lightning talk permits. But this test essentially types in an invalid email, an invalid password in our app, and clicks the login button, just for the sake of brevity, so we can talk about Espresso and what we've done to wrap around it at TradeMe. The whole of this class fits within 37 lines of code. Espresso is very good at getting you up and running quite quickly, and usually everything's fairly well self-contained. But there's a bunch of problems in here from a maintainability perspective. We've relied heavily on Espresso here, which means that we're vulnerable to any changes that might happen when that gets updated in the future. We've got a large potential blast radius of any changes that might happen within our R class that may come through if we just rename things or refactor how we do stuff within our app. And then we've got all this dependency on JUnit for kicking off the test itself. And within that, that could get quite repetitive as we get dozens and dozens of tests. And then we have the test, which is where we should really be focusing our time. And it's a little hard to read. You have perform, click, perform, click, perform, click, a lot of Espresso-specific stuff, which is a little hard to understand, and a lot of repetition there. And there's a uniqueness problem here too. I work at a company called TradeMe, where we have 100 or so engineers, and I could get 5 of them in a room to write the same test, and in this style, they could all come away with very different tests, with very different IDs as well, which makes a bit of a maintainability burden. And if we were to try to extend this out to support foldables or tablets, that could be a little hard for us to do. We might have to write separate tests. Luckily, in the testing world, there's a proven solution for dealing with this, which is the page object pattern. And if you were to Google that and then grab one of the first results, you'd probably come up with a definition sort of like this, which I've got quoted in the source here. Page objects can be thought of as facing in 2 directions simultaneously. So facing towards the developer of a test, they represent the services offered by a particular page. And facing away from the developer of that test, they should be the only thing that has a deep knowledge of the structure of a page or part of a page, which unfortunately this test class that I've followed the documentation of online doesn't have. So what we need to do is we need to implement that here. Now, despite the name, you don't need to write a page object for every page of your app. You can actually be more granular than that. So what I'm going to begin with here is an object that we're going to call app in our page objects. It's going to be the beginning of all of our tests in this framework that we're working on today. And this is just a little navigation footer at the beginning of our app. So we're going to create an object called app. We're going to move the way that we found the on view, or the view matcher there. We're going to move that as a private variable, and we're going to call that in a public function, which has a return type of a different class. And that is where we're going to put our view action that matches with that. So we're going to take that concept and we're going to apply that to the next screen as well. So once you've clicked that button, then we're going to go to another class where we're going to have another private identifier for another button and another public function where we're going to click that button, which will return itself to another class. Back on the tests itself, that means that we can just write one word, app, and then dot, and then our IDE will autocomplete what is available to us within that list of functions, which is at the moment just one, but as we grow our test suite out, we'll get more and more. This is quite cool because the developer of a test doesn't need to know anything about how that page works. So we can just say, yep, enter that one, please, and then click dot, and then we're being magically taken to another class where we can now fill in another function. We can just click that from there. So we're auto-completing the test creation at this point, provided we've written good page objects. We'll apply that logic too to our login screen, which is where the meat of our tests is actually sort of going to be happening. The one difference of here is that obviously we have more functions, more identifiers, and then we also have two different return types here, whether that's going back to that bottom navigation element or staying on the screen itself. So as far as what a test author would see, they would see dot and then autocomplete to type the email. The neat thing about this is they'd be then prompted to say what email they would like to type. Similarly, the password, type the password, be a prompt to type the password to. And then finally tapping the login button. And within, 6 or so lines, we've managed to refine our test down to something that's quite readable, which is really exciting. On the test class itself, we've been able to remove half of our import statements, which means that we're no longer vulnerable to changes in Espresso here, and we're no longer vulnerable to changes in our R class here either. So that's cool too. We've taken 37 lines of code down to 25 for the test itself. And the test, I would argue now, is a lot more readable. There's zero repetition, and there's a very narrow definition of what each function can do, which ideally should help us long-term with maintainability. There's a lot of component reuse possibility, which should make it easier for people to write other tests that complement what this test does. So if I was to test login with a valid email, I would be able to essentially write the same test, but now with a valid email. So are we done? Unfortunately, no, we are not done. We've still got a long ways ahead. So we've still got a lot of things here with using JUnit and how we're going to manage executing our tests. If that was to be scaled out across dozens and dozens or hundreds and hundreds of test classes, depending on the size and the scope of your app, that could be problematic. And it might be really hard to run that in a build pipeline too. So what we've done at TradeMe is we've removed all of those, and we've created a base helper class, which all test classes extend. And we'll get into that now. So we've basically just moved some of that code to this root level class that everything extends. And we've also added in some JUnit special for describing the test that is underway at the time, which will help us with logging and reporting. So there's not too much to this class. It's pretty easy to do. And that, in the process, is refined our whole test class down to 19 lines of code, the bulk of which is actually done elsewhere. So I think you'd think that we're pretty good from a maintainability side, right? Unfortunately, I'm still going to challenge us to go a little bit further, a little bit deeper. So in the login screen where we had the bulk of our functions, let's have a chance to have a think about what Espresso is and what it does here. So the way that it works is that it uses view matches to find a non-ambiguous object on the screen. You can think of these as expected values that can be compared against actual values. It makes it really powerful to use them for testing purposes, even though it maybe wasn't the original intent of how view matches work. But it's been a very useful case to have put into Espresso, and Espresso's on-view API helps us find those. Espresso's view actions API helps us interact with them once they've been found. The problem with trying to remove a bit of dependency on Espresso to make our tests and our page objects immune to any future changes of Espresso is that you can't really do that. They're sort of intertwined. You have to have the both at the same time. So the way that you could get around that would be that you could create an extension function to perform a viewActions.click on the current matcher like this, which would be fine. We could then rewrite our page objects to look like this, which is starting to look pretty readable. You've got your thing that you're matching to, and then the action that you're performing. We could do something similar for type text as well, where we're again just extending things out a little bit and then using Espresso's on-view perform viewActions.typeText string. Which, if you ended there, you'd probably be doing okay, I think. But we had an additional challenge where we really wanted to centralize how we did our logging, customize environmental timeouts depending on where we were at, and have the ability to enhance things even further as we broadened our test suites out. So we really needed to remove that Espresso on view and replace it with what we've done as an internal function that we've called execute here. And this execute function takes a variety of arguments, one of which would be action.click, action.typeText. And we define action here, which is where, pun intended, all the action happens. Literally, that's where all the action happens. So we've moved all of Espresso's view actions into here. So this is how we click, scroll, type. So everything's all encapsulated in the one class. So if we were to theoretically ever move away from Espresso's view actions, it would be very quick and easy for us to replace the stuff that's in here. And execute merges it all together. So this is our internal function that checks the type of the matcher that we're on, whether that's a view or a data. And we pass the argument for the command, and we perform that command as appropriate. This is probably going by very fast, but the idea generally is that we've centralized everything into one overall function. And then that should hopefully make it easier for us to change things in the future or guard against changes in the future too. It also helps us centralize our logging so we can define what we're doing at any one time and also prefix our logs with a particular text. So we've encapsulated this all into a library that we've called harness, which means that in logcat, all you have to remember to type is harness, and you can filter out everything except for your test that's under instruction at the time. You can have a look at what it is doing at any one time, which is a very powerful debugging tool, which will help you with maintenance and make sure that your tests can easily be debugged. So back to our page objects. In doing all this, we've managed to remove 3 lines of import statement from every page, which is always a relief in my mind. And then we've also got the ability to centralize our logging, have variable timeouts. We're guarded from any changes that might come through the pipe later from Espresso clicks. And if we wanted to add extra try catches or differentiate things later, then we could. We've done that all in the same way, whether it's a click or type text. So I would argue we've pretty comprehensively closed off the maintenance burden. Our last couple of challenges are easily broken tests and slow tests. What we found at TradeMe is that the majority of the time that tests fail, aside from poorly maintained test classes, is probably a dependency on data that has shifted, or your environment's down, or your environment's slow, or something third party is interacting with things that is in an unexpected way, completely separate from the scope of your test. So what we've embraced at TradeMe is a mocking approach for our UI tests. And we've done that with a library called OK Replay, which is made by Airbnb. That is a really useful tool which allows you to essentially record and replay HTTP connections. This is also useful from a maintenance perspective because you can essentially hit record and record all of the API interactions from a particular domain or way of targeting what your app is doing, and then replay those later when you're running in a build pipeline or across everyone's different computers and that sort of thing. So we're really grateful for that, and it's a very useful tool in our toolkit. And we've added that into that base helper class that we created to get around the JUnit dependency. I won't bore you too much or go into too much detail about how to implement that. They've got very extensive documentation, and we were able to largely follow it just with a couple of minor modifications. But basically putting that into that base helper class, which every single test class extends, means that on every test class, all we have to do is pass through one additional command about whether or not we're in record mode or replay mode, which is easily toggleable from there. And the neat thing about that is that we've essentially solved, from our perspective, easily broken tests, and we've sped our tests up dramatically. We don't have to wait for API interactions. Because we bundled a lot of that stuff around execute and actions into one library that we called Harness, we've been able to share that out internally within our apps across 3 different apps that we support at TradeMe within our Android code base, and we've done the same for our iOS code base as well. So we've got 3 different login pages from 3 different repositories, all using the same style of working. Which makes it a lot easier to jump between repositories. And we've actually proven this too with our iOS code base as well. You've got an iOS test on the right-hand side and an Android test on the left, and they look almost exactly the same based on the way that we've worked here, which is very useful if you are the automation practice manager like I am across a large variety of employees. This is our logo from our company, and makes it a lot easier to switch between code bases. So yeah, that's my talk, and that was making Espresso sweeter. Yeah, I'll hand over to our facilitator to hopefully get us some Slido questions. At the moment, I can't see any Slido questions, so I'm assuming that people have just had to frantically try to keep up with a barrage of code there. I apologize if that was what happened. Hopefully, we were just sort of going for high level concepts by way of showing you the code. Do we have numbers on how much faster it is to run tests with OK Replay? That's a great question. I don't actually have those numbers offhand, but what we have found at TradeMe, and I guess it depends on what type of environment you're running on, but we're in the middle of a big transition to the cloud at the moment. Previously, our test environments were running on-premise and on-premise-based servers, which meant that sometimes we would find vast ranges of different speeds for our API calls. Stuff that would take 40 milliseconds in production might take upwards of 30 seconds in our on-premise environment, depending on how much contention there was. So this removes that contention. Similarly, we're in New Zealand. We're very far away from a lot of cloud provider hostings as well. So there's actually a 40 millisecond latency as you cross the Tasman from New Zealand to Australia. So even removing that for every API call adds up. You can basically make sure that everything's hyper-local to the assets that are stored in your repository. So I don't have the exact numbers, but I mean, it ranges between seconds and milliseconds, but every bit counts in speed, which is useful. However, there is a huge maintenance burden for including mocking frameworks, which is why we went with something simple that we could just record over the top of and replay over the top of with something like OK Replay. Hopefully that answers your question, Anonymous. And then they've got another question here, which is better to use robo-electric tests or instrumentation tests. Do you know what? I'm not even sure what robo-electric is. I'm so sorry. I can try to get back to you in the talk, but yeah, I'm sorry. I'm not really sure about the answer to that. If I could maybe take your question about what I think you're asking, at Traby have emphasized using native frameworks, which are baked into the code base of choice for running our UI tests, as opposed to using something like potentially Appium or other tooling like that. One reason for that is to emphasize make sure that we stay up to date with exactly what the vendor is providing, whether that's Android itself or iOS respectively. But another is that we can make sure that we keep everything within the IDE as well. But I am truly unqualified. I don't even know what roboelectric is. I'm sorry. I'll try to get back to you. And there's another question. You made the view action child as a sealed class. Should we use composition instead of inheritance? That is a really good question. I'm going to have to take a pass on that one too. I'm sorry, but we can get back to you in the talk afterwards as well. Sorry, my mind might be a little bit fogged over having just given this conference talk at a very blistering speed. So we'll try to get back to you on that one in the talk chat afterwards too. I'll take a screenshot now to make sure that we do. Okay. So we're getting I think we might be at time. So I might wrap things up from here. Thanks very much for your participation and active listening. We've got another talk too, in login screen class, why do you create a new instance of login screen instead of returning itself? That's a great question. I think we're emphasizing yeah, we're gonna have to look at that. Some of this is demo code, so I'll have to look at how we properly do that in our real code base. So again, I'll try to get back to you that on the talk chat. Cool. I think we'll wrap things up from here though to make sure that the next presenter can get ready to go. But yeah, thanks very much for everyone's participation. I hope you've learned something and clearly been watching the code as it streamed by very closely. Thank you very much for that. Cheers.